All right, we are going to dive into chapter 7 today, and we're going to start with 7.1, nth roots and rational exponents. So we're going to kind of familiarize ourselves with stuff that we already know. We do know that the square root of 4 is 2. The square root of a negative 4 is 2i. That is not real. And we are not going to deal with imaginary numbers in this chapter. So if there's a negative on the inside, we're not going to take the square root. We're not going to take other roots that we will find out about later on. Next, we have the third root of 8. This is something that you may or may not have seen before. Now, we have to know for the square root what number times itself gives us 4. That's 2 times 2 gives us 4. The cube root is what number times itself 3 times is going to give us 8. And that is going to be 2, because 2 times 2 is 4, times 2 is going to be 8. Now there is a slight difference with the cube root because we can have a negative on the inside. A negative 2 times a negative 2 times a negative 2 gives us a negative 8. So if we have a negative on the inside, it's okay. As a general rule, if we have the square root, no negatives on the inside. If you have a cube root, you can have a negative. And that's actually going to be true for all even roots. You can't have any negatives on the inside. For all odd roots, you can. So the square root, this is an imaginary 2. If it was the 4th root or the 6th root or the 8th root, no negatives on the inside. If it's the 3rd or the 5th or the 7th or the 9th, the negatives are okay on the inside. This one, now instead of taking the root, we're going to square things. That squared is only connected to the 3. So this is actually a negative 3 times 3, giving us a negative 9 as our answer. Slight difference from our next one, since the whole negative 3 is in parentheses, that's a negative 3 times a negative 3, giving us a positive 9. So you have to pay attention. If there are no parentheses, such as we see here, that exponent is only connected to the number directly to the left. If the negative is not in parentheses, the negative is not being raised to that power. So this is 3 times 3 times 3. 3 times 3 is 9, times 3 gives us 27. The negative is in parentheses, so a negative 3 times a negative 3 times a negative 3. We have 3 negatives, so it's going to be a negative 27. That's why we can take the cube roots of odd roots, because if you have a negative an odd number of times, your answer is going to be negative. If you have a square root or a 4th root, that means you'd have 4 negatives, which means all the negatives would cancel out, and you would have a positive answer. So there's no way to take an even root of a negative because it's not possible. We're going to have 2 main forms, radical form and exponential form. Radical form is the n is the root. So we're taking this square root is the 2nd root, the 3rd root, the 4th root, the 5th root, and m is what the number on the inside, what exponent that is being raised to. You will be able to see this in both forms, and you should be able to work with both forms. The n is always on the outside of the root, but the m can be inside the radical, or it could be that whole thing raised to the m. And exponential form. So the exponential form is just when you have your base raised to a fractional exponent. And we are going to have to work back and forth between these two pieces. So it has to be kind of second nature from going from exponential form to radical form, from radical form to exponential form. Notice the m is right next to the a. The m is right next to the a. So the way I always remember it is the m stays with the a. So the exponent, the numerator of your fraction, always stays with the base. And the bottom of the fraction, the denominator, is going to be whatever root you are taking that number to. If you forget which number goes where, think of a simple one. If we're taking the 3rd root of 8, we know that's going to be 2, because 2 times 2 times 2 is what gives us 8. Therefore, we can rewrite it as the cube root of 8 is equal to 8 to the 1/3. So think about it as a simple example. If you were to write it the other way, 3 over 1, you would get a big number, 512. That would be 8 times 8 times 8, 512, which clearly isn't true. If you are taking the root of something, the number is getting smaller. If you're raising it to the power, it is getting bigger. So take a simple one and test those numbers out and see which way is the correct way if you end up forgetting. So we are going to work on going from radical form to exponential form. So we've got the cube root of 11. There is no exponent written in there. Remember, if there's no exponent, it's an imaginary 1. So the base number is 11. 1, the root is 3. So that's 11 to the 1/3. Here my base is x. And I always say whatever is attached to the x, that's going to be the numerator. And we're taking the 4th root. So that's x to the 3/4. You can see that squared on the outside, which sometimes may mess you up just a little bit. But that is going to be the numerator. Whatever the root is, that is always going to be the denominator of your fraction. So that's y to the 2/6. Now here is the tricky part. Your answers must be in simplest form at all times. So anytime you can see that those two numbers can reduce, your radical has not been broken down all the way. We want to reduce that fraction, and 2/6 reduces down to 1/3. And next we have 4 squared, 4th root, so that's 4 to the 2/4, which is 4 to the 1/2. And you know that you're going to simplify it because, again, we see that those two numbers can reduce. Those two numbers share a factor. 4 to the 1/2, this may be more confusing than the actual radical form. We know that 1/2 is the square root, and the square root of 4 is just 2. If you wanted to stay along with the exponents theme, 4 can be rewritten as 2 squared. If I take 2 squared and I raise it to the 1/2, 2 times 1/2, because that's a power to a power, gives us 2 to the 1st, which is what we just found. So the good thing and the hard thing about exponents is there's lots of different paths you can take to get to the right answer, which a lot of people do like because you kind of have a little bit of freedom in the process. Some people don't like that because some people like a set formula to get to the answer. This way there's lots of different ways to navigate to the answer. And then we have the square root of n to the 6th. Don't be fooled by this one. The square root, just like if we have an exponent like we did in the first one that's not there, it's an imagined 1, the square root means that we are taking the 2nd root. So this is really n to the 6th over 2. 6 divided by 2 gives us n to the 3rd power. Alright, let's go in the other direction. Let's start as a fractional exponent and move our way into a radical form. 5 to the 1/2. 5 is the base, so 5 is what's going on the inside, being raised to the 1st power, and that is the 2nd root. You do not have to write the 2, and you do not have to write the 1. This is really just the square root of 5. You can if it makes it easier for you, but you don't have to. Just like if I gave you x, you don't have to write it x to the 1st power. You just write it as x, and that's the assumed 1st power. Next one, x is our base. We know we're going to have a square root. The bottom is the root, so that's the 5th root, x cubed. You can also write this as the 5th root of x raised to the 3rd. I find this way to be much easier, so I will always show you this way. I will never probably show you this way, but you do not have to know this form, so if you see it come up in a problem, you know what to do with it. Now we have x to the negative 3/4. We've known from previous videos that the negative exponent, not a negative coefficient, but a negative exponent, means we need to take the reciprocal of it to make it positive. You move it and you lose it. So now we have 1 over the 4th root of x cubed. If you remember, we cannot have radicals on the bottom. That's true for square roots, that's true for cube roots and 4th roots. So eventually we're going to learn how to rationalize this, but we'll come back to this. We're not going to do that today. This technically is not a correct answer. It's not in simplest form. Keep that in mind. So don't say, oh, well, in the video you left it there. We will come back to this and learn how to rationalize that a little bit later. And our last one, 6 to the 3/7. 6 is the base, being raised to the third power, taking the 7th root. When you have number bases, you do always want to check to see, can I simplify that base? Can I rewrite 6 the way we did in this problem? 4 could be rewritten as 2 squared. In this case, 6 can't, but anytime you have a numerical base, you always have to double check, can I rewrite that base? Alright, let's flip on over to the back page. We are going to evaluate these. Since I'm evaluating, that means I have all number bases, and I'm going to be able to simplify my answers semi-easily. So we are taking the 4th root of 81. I want to break down 81. 81 is 9 and 9, 3 and 3, 3 and 3. Now we know for the square root, when our root is 2, every pair goes to the outside. We need pairs. If we have a 4th root, instead of needing 2 to go to the outside, that root tells you how many you need to go to the outside. So I need all 4. I need a group of 4 in order for it to move from the inside to the outside. So this answer is just 3. Like I said before, lots of different routes to take to get there. I also could have said, okay, well, I can rewrite my base of 81. 81 is really to the 1/4 power, and 81 is 3 to the 4th. So this is really 3 to the 4th to the 1/4 power. A power to a power, I multiply those numbers to get 3 to the 1st, which is what I found going the other direction. So if you prefer to break down the radicals and see how many you have to bring to the outside, that works. If you prefer to rewrite the base, that works as well, just as long as you do some method of checking to see if something can break down. Cube root of a -27. Some of these we'll be using so often that you'll get used to them and you won't even have to go to your calculator and check. I'm taking the cube root of a negative. That's okay, because if I have a negative 3 times, my answer is a negative. So I know right away that I'm going to have a negative in my answer. If I'm taking the cube root, I'm trying to figure out what number multiplied by itself 3 times is going to give me 27. You can rewrite 27. We can do a factor tree. That's 9 and 3, 3 and 3. I have exactly 3 3s. I need 3 of those to go to the outside. So this answer is just a -3. Our next one, we have the 4th root of 10. I try to break down 10. This is 2 and 5. I need 4 of them to go to the outside. I can't rewrite 10. Like I could rewrite 81 as 3 to the 4th. I could have rewritten 27 as 3 to the 3rd. I can't rewrite 10. I don't have any groups of 4, which means this is already simplified. Sometimes you just can't break it down any further, which is fine. Don't force something to happen that's not there. 16, I'm sure most of you know that 16 is 4 squared, but 4 squared can be broken down even more. 4 is 2 squared. So if I have 2 squared, 16 is actually 2 to the 4th power. And you can go directly from 16 to 2 to the 4th. That's being raised to the 1/4. 4 times 1/4 is just 2 to the 1st, so our answer is 2. Alright, we've got 2 more left. I want you to press pause and see if you can do the last 2 on your own. Alright, let's see how you did. I rewrote my base of 4, 4 squared, 4 is 2 squared, and then that whole quantity is being raised to the 3/2. I multiply that, I get 6 over 2, which is just the 3rd. Do not leave your answer as 2 cubed. 2 cubed can be evaluated as 8. 2 times 2 times 2 is 8. And then we have a negative exponent, so we move that to the bottom to make that exponent a positive. Our same rules still apply. You have to have positive exponents in your answer. 8 can be rewritten as 2 to the 3rd power. 3 times 2/3 is 6 over 3, which is just 2 squared, which leaves us with our answer of 1/4. Now our next ones are not going to break down as easily. We have the square root of 32. I'm going to break this down: 2 and 16, 4 and 4, 2 and 2, 2 and 2. We have the square root, which means that's the second root, which means we need groups of 2 to go to the outside. I've got a group of 2 there, I've got a group of 2 there, with 1 left over. I am bringing 2 2's to the outside with a 2 left over. You're going to multiply those to give us 4 square root 2. Now we've got the cube root of 16. Break that down: 4 and 4, 2 and 2, 2 and 2. Because it's the cube root, I need groups of 3, and I've got a 2 left over. That group goes to the outside, cube root of 2 left over on the inside. Fourth root of 64. 64 can be broken down as 8 and 8, 4 and 2, 2 and 2, 4 and 2, 2 and 2. Since it's the fourth root, I need groups of 4. So I've got 1, 2, 3, 4. I've got one group of 4, and I've got 2 2's left over. So those 2 2 stays on the inside, and that is going to give us 2 to the second power. Again, this is where it's going to become extremely tricky. This is not simplified all the way. I don't have enough groups to go to the outside, but I see that those can be simplified. 4 and 2 can be broken down even further. 2 goes into 4 2 times. So this is really 2 to the square root of 2 by simplifying that fraction. And remember, you don't have to write the root 2, if you don't want to. Fourth root of 48. 48 is 4 and 12, 4 and 3, 2 and 2, 2 and 2. We need groups of 4. We have a group of 4 2's with a 3 left over. So that is 2, fourth root of 3. Alright, we are almost done. Stay with me. Alright, so now we are going to simplify with variables. Sometimes variables are easier, sometimes they're harder. We've got the square root. That means I need groups of 2. This is the square root of x to the 4th, so that's x times x times x times x. We need groups of 2. That gives me exactly 2 groups with nothing left over on the inside, so this is just x squared. So whatever that root is, you want to see how many times can I divide that. 4 divided by 2 gives me 2 groups exactly. The cube root of x to the 3rd, I need 3. I have exactly 3, which allows me to bring one group of 3 to the outside. Cube root of x to the 4th, I need 3 of them, I have 4. I can take one group of 3 to the outside. 4 minus 3 leaves me with 1 left over on the inside. And we've got the fourth root of x to the 10th. If we have 10, that means that we have 2 groups of 4, because 4 times 2 is going to give us 8. And if I've taken 8 of them to give me 2 groups on the outside, that's going to leave me with 2 left over on the inside. Once again, we have to be very, very careful. Even though we can't take any more of those groups out, this is really saying x squared, or x to the 2/4 power, which is x to the 1/2, because that's your exponent, that's your root, so that's 2/4. So you must rewrite this as x squared square root of x. And that is always that little tedious little detail that is forgotten. And if you don't do that, your answer is not in simplest form. Alright, here are our last 2 problems. We want to simplify it when we have a number and a variable base. Cubed root means we need groups of 3. So I break down 8, 4 and 2, 2 and 2. Well, I have exactly one group of 3. X to the 3rd, exactly one group of 3. Y to the 6th. If I need groups of 3 and I have 6, I have exactly 2 groups, which means nothing was left over. If nothing's left over, then nothing can be left on the inside of the radical, which means there is no radical. Moving on, 24. This time we need groups of 3. 24 is 4 and 6, 2 and 2, 3 and 2. I've got one group of 3 2's. X to the third, I've got one group. Y to the fifth, I only have one group there as well. Now what's left over? From that 24, we had a 3 that could not go to the outside. All of our x's went out. We had y to the fifth. We needed a group of 3. We took 3 away, which leaves us with 2 y's on the inside. Alright, so just make sure that you really pay attention to that root that tells you how many groups you need, and then double check that your answer is simplified as far as it can go. I know it was long, but this was a very, very detailed, and you've got to make sure that you have today's video down. Alright, see you later.